Hello. So today, this session is adapting to future fire across ecosystem in the North Central region. It is being hosted by myself. I'm a postdoc with the North Central CASC in series at Boulder, and also Kim Davis, a research scientist at the University of Montana. So this, you can see the list of presenters, the different titles we're going to cover today. And so the main reason we put this on is our research spans ecosystem. And with climate change and all the fires that have been happening, we wanted to present on the current state of fires and then some of the future fires in some ecosystems and how we can help managers adapt to that. So we're going to start off with a quick little video, and then I'll hand it over to Kim before we go into our presentation. So I'm going to stop sharing and then I'll share a video. So.
On December 30th, 2021, the unthinkable happened. Peaceful Colorado, looking forward to celebrating the start of a new year, endured an unprecedented evacuation due to a rapidly spreading winter wildfire called the Marshall Fire. It is the most destructive fire in Colorado history to date in terms of cost, numbering in the hundreds of millions, and in losses of structures, with over 1,000 homes and businesses destroyed. Fire is an integral component of numerous terrestrial ecosystems. However, recent record-breaking events, unprecedented losses, and escalating suppression costs have raised concerns over a new normal of increased fire activity and the onset of an era of megafires. Wildfires are extremely costly, not just in the dollars used to suppress them, which number in the billions, but in the millions of acres of forest that get consumed as well. Annually, wildfires burn more than 7.5 million acres, with most of this destruction in the West. This is equivalent in area to the Grand Canyon in Arizona, 6 times over. New research led by scientists at Colorado State University, the U.S. Geological Survey, and the North Central Climate Adaptation Science Center has found compelling evidence that average fire events in regions of the United States are up to 4 times the size, triple the frequency, and more widespread in the 2000s than in the previous 2 decades. The most extreme fires are also larger, more common, and more likely to co-occur with other extreme fires.
One of the challenges of land and resource management in the North Central region here in the United States is increasing wildfires, and the need is to think about the future. What areas might be more susceptible to fire in the future? What will be how fires will behave in the future, and also what the exposure is. And fire threatens both natural resources, national parks, species and habitats, and our communities.
When it comes to the Marshall Fire, how did it become so destructive in a relatively short time frame? Well, it was a perfect storm of conditions. An unusually wet spring supported the high growth of grasses in the prairies that cover much of the open space in Boulder County. This provided the tinder. Then extreme drought conditions, a very warm and dry August to December timeframe set in. Coupling this with a downslope windstorm that produced gusts exceeding 100 miles per hour, with sustained winds of over 45 miles per hour for 8 hours, led to a rapidly spreading winter wildfire. Anthropogenic effects, or the human touch, are likely influencing fire patterns across the country, not only indirectly through regional drying, like that seen here in the West, but also in a direct manner. During the last 2 decades, for example, human ignitions caused 84% of all fires in the continental U.S., representing approximately 40,000 fires per year. By introducing ignitions into dry landscapes, humans have tripled the length of the fire season and expanded the size of fire-prone areas. The future is fire. Thus, in order to adapt and build resilience to impacts, planners and stakeholders must account for how fire is changing and how it is impacting vulnerable ecosystems and communities. Managing grasslands and making use of prescribed burns are some of the most effective tools we have in dealing with the intensity and spread of fires, by reducing those fuels that would otherwise be available for a wildfire to consume.
All right, that was our quick little intro by a video made by Uliana. Now I'm going to hand it over to Kim to do a quick overview before we do our presentation.
Okay, so thanks, Jilmarie, and thanks everybody for coming. We're excited to have you here today to talk about adapting to future fire regimes across ecosystems of the North Central region. And I think that that video really set us up well for the conversations that we're going to have today. So we're going to start, as Jilmarie gave a little bit of an overview, but basically we'll start with a brief overview of the impacts of climate change on wildfire, really briefly, and then we'll start to talk about some of the humans' impacts on wildfire before we move into presentations about our specific different types of ecosystems we have here in the North Central region. And so we do have a variety of presenters. We're trying to keep our talks short, but it will still be about 35 minutes of presentations, followed by some breakout discussions. And this is what we're really excited about, to hear from you, how you think management can really help us adapt to these changes in fire regimes that we're seeing. And if anybody has been starting to implement some of these and strategies and what's been going on in their ecosystems. So when we do breakout groups, we are thinking about splitting us up by ecosystem. So Jilmarie is going to launch a poll, and you can choose whether you'd like to be in the discussion about forests, grasslands, or sagebrush. So go ahead, and when you get a chance, answer those questions. And I'm just going to get started. So just to set the stage a little bit, I think we're all aware that wildfire area burning in the West is increasing. And this figure is really showing how much it's increased since the 1980s. Recent work from CU Boulder that the video referenced found that the mean annual area burned has quadrupled in the West between the 80s and 90s and the 2000s. And we're starting to see more area burning, not just because we're having more fires, but also because we're having bigger fires. And one of the main reasons that we're having this increase in area burned is because climate is a key driver of annual area burned. And we know this from a lot of literature. So from the paleoecological literature, as well as current day examinations of the relationship between climate and wildfire. And so this is a strongly established link between climate and area burned. And this is just one example that I'm showing here, where you can see we have fuel aridity on the x-axis. And as we get drier fuels, we start to see more area burning. And you'll notice it doesn't stand out at first, but that little black point near the top is 2020. So 2020 really was a big jump in area burned. But all those red points are the 2000s. So we're really starting to see drier fuels and more area burning. And this is also partially leading to a longer fire seasons. And so this is part of the reason why we're seeing more area burned. In some areas like California, we're not even really having a fire season. It's just any time of year. But even in other parts of the country, and so Colorado is a great example of this, where we're starting to see fires outside of when we normally would see fires. So the video referenced a fire that happened in December. This photo is showing a fire that started in mid-October a couple years ago, and it burned through high elevation subalpine forests in mid-October, which is pretty unheard of in these areas. And as I think those of you in Boulder know, currently there's a whole bunch of wildfires being started in Colorado. And so because of this strong link between climate and wildfire, researchers have actually been able to figure out how much of the increase in area burn that we're seeing in the recent years is due to human-caused climate change. And they found that 45% of the increase of the total forest area burned between 1984 and 2015 is actually due to anthropogenic climate change. And so as we continue to have climate change, we might expect to see continued increases in annual area burned. And this is specific to our forested ecosystems in the West. And what I'm showing here are these projections into the future, incorporate different scenarios of feedbacks. So in a lot of forest types, we might see a decrease in the probability of burning in the first 5 to 10 years following a wildfire because there's fewer fuels. And so these models tried to account for that while also incorporating the effects of climate change. And they still found that even with these types of feedbacks, we expect there to be more area burned every year in the future. And so because we're seeing these big increases in area burned, what we're also starting to see is that some ecosystems are experiencing ecosystem transformations. And because of this, a group of federal land managers and scientists have been working together over the past few years to really develop a good framework to help managers manage in the face of ecological transformations. And this is the Resist, Accept, Direct framework, which I think maybe some of you are probably familiar with, but I just wanted to bring it up here because I think it could be really relevant to some of the discussions that we're having about adapting to these changes in fire regimes. And so this basically the idea is just when you're faced with ecological transformation, there's really only 3 choices. You can try to resist the trajectory of change and manage for historic conditions or currently acceptable conditions. You can accept the trajectory of change with minimal intervention, or you can try to direct the trajectory of change to more desirable conditions. So just keep that in the back of your mind as we're going forward. And now I'm going to pass it over to Max Cook, who's going to talk a little bit more about the impacts of interactions between humans and wildfires. So thanks, Max.